Recently, while investigating in class, you've hopefully realized that a certain form of an equation corresponds in very specific ways to its graph. In this case, it's called slope-intercept form. You guys will recall that the slope of your graph is if you choose any 2 points on the graph and you look at how you have to rise to get to it and your run. In other words, your change in y over your change in x. To go from this point to this point, for example, you had to go up 1 and then you had to go over to the right 2. To get between this point and this point, you had to go up 2 and then you had to go over 4. No matter which pair of points you picked, in this case, this one, your change in y over your change in x was 1 over 2. In this case, from this one to this one, it was 2 over 4, which also simplifies to a 1/2. So either way, your rate of change is still a 1/2. And you notice that that corresponds to this part of your equation that lies right in front of the x. You'll also have noticed that the graph crosses the y-axis right here at a -3, which just so happens to correspond to this part of the equation. Because this particular form of an equation gives you, and this works for every single linear function that's in this format, because it gives you where the graph hits the y-axis. Remember, that's also called the y-intercept. That's the name for the place that the graph hits the y-axis. And of course, you guys are very familiar with this part. This is called your slope, aka your rate of change. That is the reason that this form of an equation is called a slope-intercept form, because it gives you just outright the slope and the y-intercept, as you can tell from the graph. Now, what makes this form of the equation so nice is that it's really super easy to graph compared to some of the other ways we've done it. Before, when we had input and output tables, the only way we knew how to graph a linear function was to pick a number, put it in for x, so 0 times 1/4 would be 0. 0 minus 1 would make this y a -1. Then you would have to graph it that way and keep picking points until you could find enough to connect the dots. Now that we've got slope-intercept form, it is so much easier. Let me show you how. So first of all, because this is the y-intercept of the function, we know that the graph is going to hit right here at y equals a -1. Oh, I should point out to you guys that this handout right here that you've been given actually has this linear function on it, so please make sure that you are following along and graphing it with me. Should have reminded you that a second ago, sorry. So we know that this is where the graph is going to cross the y-axis. We also know that this 1/4 represents our rate of change, which means if you pick any 2 points, your change in y over your change in x. So your change in your y values is going to be 1. Your change in your x values is going to be a 4. What do I mean by that? So we know for a fact that this -1 is going to be 1 point on the graph. So now to get to our next one, follow the rate of change. I'm simply going to go up 1, just like the top number in our rate of change. Then I'm going to go over to the right, 1, 2, 3, 4. So the next point on my graph will be right here. I know that it's slanting upwards because it's a positive slope, so that's how I knew to go up and over to the right instead of down and over to the right. Now, I don't have enough room here on the graph that's given to me to go up and then over 4 more again, but that's okay. I can actually go back to this original point right here, and I can go down and to the left, 1, 2, 3, 4, and that'll give me a point in this direction. When I was in school, most algebra teachers would make us get 3 points on the line, then we were allowed to connect the dots. So once you've got your 3 points, simply take your ruler or whatever you choose to do, connect your dots, and voila, here is a graph of that linear function. Remember that you need arrows on either side. That just tells you that technically you could keep graphing this function forever and ever and ever. It would keep going on in both directions. It's just that we don't have enough graph paper to do it. So again, the way that I figured out the graph of this linear function, I'm going to show you one more time just using this particular one. I looked at my equation. I saw that it's in slope-intercept form. The way you know that is anytime you have something that is in this particular format. And I'm going to get more specific. Why do I keep hitting clone instead of cut? Sorry, guys. Anytime you get an equation that's in this particular format, where you've got y equals, and then you have a number in front of the x, and then plus or minus another number, that is your slope-intercept form. This is your slope, whatever is in front of the x. This is your y-intercept. I'm going to give them some more precise terminology a little bit later, but that's good enough for now. So what I did again is I knew that this y-intercept is where it crosses at the -1. I knew since this is my rate of change that I would need to go up 1 and over to the right. 1, 2, 3, 4 places. I didn't make that very neatly, did I? Let's try that again. So from my -1, I had to travel up 1 and then to the right. 1, 2, 3, 4 places. I can go back in the other direction, down and to the left, 2, 3, 4 places. Then I connected my dots, added my arrows to either end. Voila, I've got the graph of a linear function. I'm going to do one more for you. That is the second one on your handout. And so let's look at our graph, or at our equation. So that +2 right there tells us that the y-intercept, that is the place that the graph is going to hit the y-axis, is going to be right there where y equals a +2. Now, I don't see a number. Before, I had a number in front of the x to represent my slope. But this time, I don't have one. Hopefully, we remember when it's just a -x, we learned this when we combined like terms also, there's technically a 1 in front of that x because there's a 1x. We just don't write it. The word for it, when we know it's there, but we don't write it, is understood. Technically, that 1 is hanging out in front of that x, but we don't write it. Now, in order to get a change in y over the top of a change in x, we have to turn this -1 into a fraction, which hopefully we know is a -1 over 1, because 1 over 1 simplifies to a 1. So your slope is 1 over 1, and we also notice that this time our slope is negative, which means that this time we're going to travel down 1 and over to the right to get our next point. Down 1 and over 1 to get our next point. Down 1 and over 1 to get our next point. If the same way we go up and over 1, up and over 1. Once I've got several of my coordinates here, I will connect my dots, add my arrows. Voila, I've got myself a linear function. Anytime that you have no number in front of the x, remember that's technically a 1, which becomes a 1 over 1. By the same token, if you have something that looks like this, 2x, remember that that's technically a 2 over 1. That's going to be important in just a second. Now what I'd like you to do is pause the video, try to graph this one on your own. See, definitely do it in pencil, just in case you goof. You just learned how to do this. And then restart the video and see if you graphed it just like mine. I'm going to assume that you followed my directions and that you graphed, and I'm going to go ahead. So because this is in slope-intercept form, I know that my graph is going to hit the y-axis at a +1. Because there's no number in front of the x, I know that the slope is actually a 1x, which is the same thing as a 1 over 1. It's a +1, which means it's going to be going upward. So in order to find my next point on my graph, I'm going to start at my y-intercept. I'm going to go up 1 and then over 1. I'm going to go up 1 and then over. Up 1 and then over. To go back the other way, I'll go down and over. Down 1 and over 1. Now I've got plenty of coordinates to graph together. Voila. I've just graphed that linear function. Don't forget about your arrows, because technically this graph could go on and on and on forever. I'm going to assume that you've paused the video and that you've tried to graph number 4 on your own. First of all, I'm going to start with my y-intercept, which is a -4. So that's my first point. This 4 over 3 is positive, which means I'm going to go up 1, 2, 3, 4, and to the right 1, 2, 3. I'm going to go up again 1, 2, 3, 4, and over 1, 2, 3. I've got 3 points now, which is usually what people require you to have. Connect my dots. Don't forget my arrows. I've just graphed myself a linear function. Number 5. The y-intercept is right here at a -3. The slope is a -3, which remember is the same thing as a -3 over 1. Because it is slanting downwards, because it's negative, I'm going to count down 1, 2, 3, and then I'm going to go over to the right 1. Because I'm out of space this way, I'm going to go ahead and go up 1, 2, 3, and over to the left. I've got 3 points, which is enough. I'm going to connect my dots. I really kind of stink at making them straight. Sorry, guys. Voila, there is a graph of my linear function. Number 6 is a tricky one. I want you to think about it for a minute. Don't just automatically look at what I do. Try to think for a second. What exactly is this telling you when it says that y is equal to 4? Pause the video, try to come up with an idea, and then restart the video whenever you're ready. I am going to go ahead and work it. So we're used to seeing something that looks like this. Y equals some number times x plus another number, which is, of course, your y-intercept. So we don't have an x, which means that we don't have a number in front of the x. So, oh dear, how do we figure out the slope? Well, first of all, the y-intercept, though, we do know we've got to start plain number. So we know that our y-intercept is still going to be right there at a 4. Now, think about for a second, what would this number have to be to multiply it by x to not have an x anymore? What number times any number on the planet always gets rid of it? Are you thinking at home what I'm thinking? 0 times any number turns that number into a 0. So that's how this ended up with no x value. This particular function has a slope of 0 because 0 times x is just going to cancel out that x to make it a 0. So that all that is left is the y-intercept, which makes y is equal to 4. Another way to think about it is that no matter what points you have on the line, your y value is always a 4. So that means that it would be all of these points right here where y is equal to 4 all the way across. It also makes perfect sense that the slope is 0 because it doesn't slant upwards or downwards. So that makes perfect sense that it's got a slope of 0. So anytime you see something where it's y equals just a number, that is your y-intercept, but it has no slope. Because the reason there's no x value in that equation is because the slope was 0. 0 times any value for x is going to cancel it out. So all you're left with is the y-intercept. Another way to think about it again is that no matter what, your y value is always a 4 in this case, which means it has to be a line that is straight across with no slope. Hopefully you've paused the video and you're ready to check. So my y-intercept in this case is a -1. My slope is a positive 3/5, which means I'm going to go up 1, 2, 3, and then over 1, 2, 3, 4, 5 to get my next point. I'm going to go down 1, 2, 3, and then go over 1, 2, 3, 4, and 5 to get my next point. I've got my little straight edge tool here, so I am going to connect these dots. Add my arrows, because remember, technically this linear function is going on and on and on. Voila, here is the graph of my linear function. Number 8, now think back to this example where y was equal to 4, and that means that no matter what, your y value is always a 4. Use that to think, now in this case, x is equal to 5. So pause the video and think about what that must mean the graph looks like. So again, this one right here, y is equal to 4, it meant no matter what, your y coordinate was always a 4. In this case, the coordinate here is 2, 4. In this case here, it's a 6, 4. Okay, all the way across here, your y coordinate is always a 4. So what does that mean x equals 5 would look like? Hopefully you've taken the time to pause and think it through. If you're thinking what I'm thinking, it means exactly the opposite as y, the equation we just saw. It means that in this case, every x value is a 5, which means it's going to be a line that goes straight up and down vertically, just like so. Every single x value is a 5. Because look at the ordered pair for this coordinate right here. It goes over 5 and then it's up 5. Oops. So the ordered pair, or your x value, is a 5, 5. In this case, right here, it goes over 5 and then up 3. I could sit here and I could pick out points all day long. The x value is always going to be a 5, which satisfies this equation. X is equal to 5. So a y equals equation means that it's going to be a horizontal line. An x equals equation is going to have just a vertical line. So now you try this one, y is equal to 3. I'm hoping you've paused the video and that you are ready to check. So of course, in this case, it just means that your y values are all 3s. So every point is going to be up here where y equals 3. So once I just add a few points, I'm going to connect my dots. Oops, I was kind of off a little bit, but I meant to get that along the x. So y is equal to 3. Again, there is no slope, which explains why there's no number and then an x. Now I've got a y-intercept of a -2 and a slope of a 3, which means it's a 3 over 1. Because it's a positive 3 over 1, I'm going to go up 1, 2, 3, and over to the right 1. I'm going to go up again, 1, 2, 3, and over 1. Now I'm going to go down 1, 2, 3, and over 1. Connect my dots. Add arrows to the ends. There's my linear function. Number 11, our y-intercept is a positive 3. Our slope is a 4, which makes it a 4 over 1. So it's positive, so it's going to go up 1, 2, 3, 4, and over 1. Kind of ran out of graph there. Then I'm going to go down 1, 2, 3, 4, and over 1 to get it going in the other direction. Connect my dots. There you go. There's your graph of your linear function. I should point out, and I probably should have done this a lot earlier actually, oops, whenever I'm going backwards, the reason that I can go down and over to get a point over here and still have a positive 4 slope is, think about it. If I go down 4, that's a -4. If I go to the left 4, that's a -1. A -4 over a -1 still simplifies to a positive 4. So that's where me going down and to the left actually still helps me to have a positive slope. Last one, our y-intercept is at a positive 5. Okay, I don't have any room to use this slope of going up 6 and over to the right 5. So I'm instead going to go down 1, 2, 3, 4, 5, and 6, and then to the left 5. 1, 2, 3, 4, and 5. I'm going to connect these 2 dots. I really should have 3, but I'm cool with just doing 2 right now. There's my arrows, and it's all graphed. So remember, the way, instead of going up and over, what I did is I went down 6, and I went to the left 5, and that -6 over a -5, negative and a negative, still simplified to a positive.